questions on this problem? Okay, I'd like to look at, if I can find my handout. I misplaced. No, it's right here, under my nose. So we had one of these handouts that we did not get the chance to look at. And I'd like any questions before we do that. Please, any questions for me? Anyone? Any doubts about the steps? Yes?
I do have a question.
Please, Kevin, go ahead.
So you had a 1 in front of the point 0.0.
Yes, I had to subtract 1 from both sides.
Okay. All right.
It has to go away because if I don't and try by mistake to apply natural log here, I'm stuck because this is a sum.
Mm-hmm.
I cannot apply log to a sum. I mean, I can, but that will not help.
Okay.
Because there is no way of simplifying it. So that's why I have to get to plain e to whatever. And that's why I peel like like an onion. So where's my previous page? So first I change this into a somewhat of a linear equation by cross multiplying. Then I needed to divide, right? So we divided both sides by 10 million. So we peeled the 10 million. Then we peeled the 1. Then we peeled this. And we stripped it to the bone. Because only when I strip it to the bone to e to whatever, then I can apply natural log safely. At any other stage, I will have to do more work. So that's why we have to clean it up to the bone. And then I can apply natural log. Is that better?
Yes, thank you.
Thank you. Okay, I am on page 5. So one problem, and then I'll answer any questions. We'll go back to anything you want. Okay, so I just want to show, for some reason the graph doesn't show here. So let's read this problem. This is problem 10. Don't ask me the page number. Let me see. So this is 10 in 2.6, yeah. And we're told that a farmer, once again, we're talking about farmers, a farmer has 200 meters of fencing. So, no, sorry, 2,000 meters of fencing. And he wants to enclose a rectangular plot, this is the rectangular plot, with X and Y, that borders on a straight highway. So let's say here's the highway. If the farmer does not fence this side, so he doesn't want to fence this side, but he only fences this, which is Y, and this, which is Y, and this, which is X. What is the largest area that can be enclosed having this restriction? He only has 2,000. And we want to find the maximum area. In other words, should we put here 200 and 200 and the rest here? Should we put here 500 and here 500 and the rest here? Which scenario gives us the maximum area? That is the question. We want to maximize this area. And we know the formula for the area of the rectangle. Who would like to help, please? Area of a rectangle, please.
Length times width.
Thank you very much. Very good. So that's the area. Good. And remember, we have to, because this area has 2 variables, we don't know how to solve any equations or deal with functions, I should say better, deal with functions with 2 variables. Not in this class. So somehow we have to get rid of one or the other. And also we have to involve the restriction. That's all we have. We are restricted. So in other words, we have 2,000 meters from this point all around till this point. So can anyone give us an equation or some relation between what you see here and 2000. Anyone, please? Anyone else? Conrad, Wes, Ethan, Blake, anyone? Give it a shot. Anyone? Brandon, go ahead if you want to save everyone else, please.
You supposed to put like the perimeter?
Exactly, of course. We are talking about the perimeter of the rectangular area. Awesome. Can anyone tell us what is the perimeter in this case? I know everyone knows the perimeter. We are looking at it. Anyone, please? Save us chart. Yes, x plus 2y. Can anyone tell us how to solve this equation for y so we can replace y in the area? Can anyone tell us what to do to solve for y? Or if you want, we can solve for x. It doesn't matter.
If you want to solve for
Yes, go ahead. Anyone, please.
You can subtract x and then divide that by 2.
Very good. Thank you very much, Kevin. 2000 minus x divided by 2. And now I'm going to plug it in here. So now I can say that the area is indeed a function of x alone. I have x in front, and I multiply by 2000 minus x over 2. I need to simplify this a little bit. So a of x, I will distribute, right? So I have negative x squared over 2, so negative 1/2 x squared. And then I have 2000 x over 2, so this is plus 1000 x. You can say, why are you doing this? And you'll see in a moment why. Can anyone tell us what type of function is this? And I'll do the step that I just did in a minute one more time. But can anyone identify this function for us? What type of function is this? We know it, we graphed it, we evaluated it, we used transformations on it. Everybody knows this function. We exhausted it. What is it?
quadratic.
Yes, thank you so much. It is quadratic. Excellent. Good. So let's do this step one more time. So I have to distribute x to these two terms. But I also would like to present it in descending order. Always. Always descending order. Always simplify. Always factored if I need to. So x times negative x is negative x squared. But I also have to divide by 2. That's how I got this term. Then x gets distributed to 2000, so I get 2000x, but I also have to divide by 2. So that's how I got the 1000. If it's easier for you to see it as x over 2 times 2000 minus x, that's fine too. X over 2 times 2000 minus x. It's another way. X over 2 times negative x is negative 1/2 x squared. X over 2 times 2000, you simplify and you get 1000x. Good. We're asked, this is a key word, we're asked to find the maximum. Okay, I have a quadratic function. Anyone remembers how to find the maximum of a quadratic function? First of all, does this function...
Find the vertex?
Thank you. By the way, does this function have a maximum? What if it has a minimum?
No, because it's negative.
Exactly, because the leading coefficient is negative, it has to have a maximum. Well done, thank you. Good. Anyone remembers the coordinates of the vertex? The coordinates of the vertex Only quadratic functions have vertices. Others have max min, but the quadratic function has a vertex. Only quadratic functions have vertices.
The lowest, the highest point on the graph.
True, but it has a formula. Anyone remembers the formula for the vertex? Please.
We are trying to find H and K, right?
We're not going to complete the square on something like this. The formula is negative b over 2a f of negative b over 2a. So the vertex, negative b over 2a, is the x coordinate, and whatever I get, I plug it in to find the y coordinate. So let's find negative b over 2a. Can anyone dictate negative b over 2a? Negative in front. Can anyone identify b? If I hadn't arranged it in descending order, I would probably make a mistake in identifying b. Can anyone identify b? Lowercase b. 1,000. Awesome. Can anyone say what is 2 times a? Brandon, thank you.
Just one.
Yes.
I got a question.
You mean negative 1. 2 times
Yeah.
negative 1 half negative 1. Yes. Any questions? Please stop me.
The negative 1/2. I didn't catch how you got there. I hadn't got to it.
Yes. So now, is this step clear? X over 2 outside, and in parentheses 2,000 minus x. Is this okay?
Yes.
Then x over 2 times negative x is negative 1/2 x squared. Is that okay?
I think so.
So maybe I can show it maybe in an even easier way. So let's do this again. So yes, go ahead, Sophie. Go ahead.
Where did the x come from outside of the parentheses? Okay.
So the area is length times width, x times y. We manipulated this and we found y, so now we are putting in here. Is this okay?
Yes, ma'am.
Perfect. So now we have x times 2,000 minus x divided by 2. I have to distribute, so let's leave it alone and let's distribute first. 2,000x minus x squared. Is this okay?
Yes.
Everyone? Brandon, is this okay?
Yeah.
Perfect. Now we separate it as we did with polynomials divided by one term. They're not two polynomials, but you know what I mean. I will separate into two fractions. This over this is 1,000x. This over this is negative 1/2 x squared. And I already arranged them in descending order. Is this better?
Yeah.
Good. So that's what we had. Negative 1/2 x squared plus 1,000x. Now we already found negative b over 2a as negative 1,000 divided by negative 1, because it was negative 1/2 times 2. So this is 1,000. So that's our x of the vertex. So the vertex has, I'm sorry, I didn't mean to write x. 1,000, comma, so we have to find f of 1,000. Okay? Or we say this is 1,000, so let's find y and just multiply them. And that's another way of getting the area. So if x is 1,000, 2,000 minus 1,000 is 1,000, divided by 2 is 500. But this y is not this y. Careful not to get confused. This is a of 1,000, and y is the width of the rectangle. Okay, not to get confused. So y equals 500, and now you can multiply these two, and you can have 500 multiplied by 1,000. And that is it. So we will tell the farmer, ma'am, sir, if you have we are restricted to just 2,000 meters, you should enclose this area so you can get the maximum in the following way: 1,000 and 500. If you do that, you will guarantee we guarantee that the area will be maximum. How much? 500,000 squared meters. Any questions on this problem? This is not new to you. You've done this in algebra. You've done this in the previous class. This is basically a review. But are the steps clear? I have a picture. It says it borders onto a highway, river, whatever. I have to denote the width by something and the length by something else. I have to write the area, the formula, length times width. I have to use this, I think it was Brendan or Charles probably, said use the perimeter. Okay, y plus x plus y is x plus 2y. That is the restriction. I'm restricted to 2,000, that's all we have. You can solve for x and y, doesn't matter, whichever it's easier. Of course, it would have been easier if we had solved for x, but it doesn't matter. The answer is the same. So we solve for y by subtracting x and dividing by 2. We plugged it back in, so we have the area. The area is x times what we just found for y. We distribute it, we realize it's quadratic. We remember the vertex. We found negative b over 2a. That is our x. We went back to the formula to find y. We multiplied these two to get the area. So 1,000 meters by 100 meters, by 500 meters will give us the largest area, keeping in mind the restriction of 2,000 meters. And the largest area is 500,000 square meters. Any questions on this problem? Okay, so we are back to the list. And please choose whatever else you want to work on. Will I find this list tonight, do you think? Yes, I found it. I'm ready. Anything you want to pick,